Welcome to this lesson on perimeter and area of two-dimensional shapes. This is probably something that many of you have examined at some point before in your mathematical endeavors, and so you'll find that it's probably not that difficult, but there is towards the end of the lesson some new stuff that I'm pretty sure none of you have looked at. So stay with me and fill out the sheet as you go and watch what I do, okay? So the perimeter is a linear straight line measurement of the distance around the outside of a shape, and most of you know that. And the most simple and basic way of identifying the perimeter for a basic equation is the perimeter is the sum of all sides. So we add up the length of all sides, we always get our perimeter. And this particular shape here that I'm showing is a quadrilateral. It's a irregular quadrilateral. And so if we had, I don't know, if I designated some distances here, 7.5, 3, and say this was, I don't know, 5.5, and then we called this one 6, we can add them up and we can say P equals the sum of all these sides. So we call this S1, this would be S2, S3, and S4, okay? And so we end up with using this formula S1 plus S2 plus S3 plus S4 and dot, 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 dot if you have more sides, and you just simply add them up. One would be 3 plus 7.5 plus 5.5 plus 6, okay? So 3 plus 7.5 is 10.5. Add another 0.5 gets me to 11. Add 5 gets me to 16. 16 plus 6, so the perimeter here equals 22. And whatever units I would apply to this, it could be centimeters, it could be meters, it could be kilometers for all that matter. We don't know. And most perimeter questions are pretty basic in that sense that we give you the lengths of the side. Sometimes we throw in some tricky things where you have to calculate some of the sides, like, using Pythagorean's theorem or some of those other things, right? Which are skills that you have learned in the past, okay? Now, the perimeter of a regular polygon, and so just to remember that like a regular polygon is some multi-sided shape. I'll draw one here, a small one, okay, where all 5 sides in this particular case are of equal length, okay? And when we do that, we can always take the number of sides times the length of one side, and we have our perimeter. So we don't have to add it. We can use multiplication because, if this is 2 plus 2 plus 2 plus 2 plus 2 is the same as saying 2 times 5, and the answer would be 10. And it's fairly straightforward. I think most kids can see that as a fairly straightforward answer, okay? So that's the perimeter of a regular polygon. Now, the perimeter of a circle is given a special name. It's called a circumference, okay? And it's just the nature of mathematics. The circles are kind of special. They don't really have any sides. And there are 2 formulas that you may have used in the past with respect to this, okay? You may have seen pi times diameter, okay, which is the distance right straight across the middle of the circle, okay? And or you may have seen circumference equals 2 pi r, and that's just because 2r is the same as diameter, and it's just the same formula, it's just slightly differently worded. If radius is given to you, r, you can use that one. If diameter is given to you, you can use this to calculate the diameter. Of course, pi, what is pi? Well, you have a calculator that'll tell you what pi is, but most of the time, if we want to think of it, it's 3.14. I think it's 3.1427, and it's called a non-repeating, non-terminating number. So it just goes on forever and ever. So there's a lot of decimal places to it if you want to get technical about it. It's a unique feature that they determined the number using circumference, I believe. So they made a circle of 1, and then they rolled it out and they started measuring that distance, and then somehow it was proven to be a certain number using mathematical principles, okay? All right, so let's move on to area. Area is a 2-dimensional measurement, okay? So when we measure things in 2 dimensions, it's slightly different. It can be measured in square centimeters. I missed the D there. in square centimeters, square meters, or square kilometers. Okay, it means how many squares can fit inside the shape. Most shapes have a specific formula for area, and you're probably familiar with many of these already, and I'm not going to spend a ton of time on them because I think that it's a bit of a bit already understood by most students by the time they've gotten to grade 9 math. But let's just quickly review some of these, okay? For example, area equals 1/2 the base times height, okay? And that's a very common formula for the area of a triangle. Sometimes I see people write it area equals base times height divided by 2, and that essentially means the same thing. One you move the half out front, and one you divide by 2 at the end, and it really doesn't matter. Either one is just fine with me. I'm not going to worry about it. Okay. The area of a rectangle is really simple. Same as can be used for a square. It's area equals length times width, and L is my length, and W is the width. Okay. Width, not wide. Okay. Now, when you get into parallelograms, it gets a little trickier. And the way they do parallelograms is we look at it from this perspective. We call this thing here the height. It's sort of the same as in a triangle. And the bottom of the parallelogram we refer to as the base. It's important that the base is one of two parallel sides. These two, you could do the base this way and or the height this way and call this the base. But it's really essential that this is 90 degrees and it measures this distance. And then the area equals the base times the height. Okay. And that's a pretty straightforward formula that is used for the parallelogram, base times height. Okay. It's really important that you don't use this side length here. If you do, that will not be the same length here. You'll get a value that's higher, and that won't work. Okay, you have to use the height as opposed to the actual side length. Okay, so when we go to trapezoids get a little more interesting. Typically what they do with a trapezoid is they also label the height, okay, same way, okay, and again, it's very important. It's not the same as this length of this side here, okay? That side length is going to be longer than this height, okay? This is a shorter distance down here. And then they label the top A and the bottom B. And these two sides are almost always parallel. Well, have to be if you're using it as a trapezoid. That's the definition of it, right? And then what we're going to do the area is we're going to say we're going to take the area equals A plus B, and there's small letters, that's important, okay, and divide it by 2. So essentially what we're going to do is take the average length of these two sides, the two parallel sides, take the average. So how do we get the average of something? We add them together and divide by the number. In this particular case, there are 2 of them, so that's why we're dividing by 2. And then we're going to multiply this by the height. And so in the same way, the base becomes like an average of A and B times the height. And that's the area of a trapezoid. All right. Now, this is probably the most interesting aspect of the area of a regular polygon is something very different that you probably have never seen before. So I'm going to kind of show you the formula. Instead of just giving you the formula, I'm going to actually kind of prove it using some triangulation for you. So the first thing you do when you're doing the area of a regular polygon is you find the center and you draw off, or you could draw off, a series of triangles like this, okay? And in this particular one, you're going to have one triangle for every side, okay? So there's 6 sides on this particular polygon, so there are 1, 2, 3, 4, 5, 6, okay? And if we wanted to find the area of them, they should all be exactly the same. If it's a regular polygon, every one of those triangles should be identical. So if we can find the area of one polygon, we're in pretty good shape, okay? Now, before I begin, I'm going to remind you that the perimeter of this equals the number of sides times one side. Okay, so whatever one side is times one side. So I'm going to start with that. We're going to come back to this and use this in just a minute. Now, there's a special measurement in a polygon that you maybe have never heard of. It's called the apotheum or apotheum, right? And it is kind of like the height, but it goes to the center. And it's given the letter A for Apotheum, okay? And again, this will be here at the midpoint or 90-degree angle. It will be a 90-degree angle if it's a regular polygon. And I emphasize, this is a regular. It doesn't work for every polygon. It only works if all sides are equal, okay? And then what we can do is we can say this is a side, okay? So now we have a triangle here, and you might recognize that this is like the base and this is the height. And so therefore we can find the area of this particular triangle, okay? Now, and we have as many of them as there are sides, okay? So in this case, there are 6 of them, but 6 is really the number of sides, which is n. So we say that area equals n times 1/2 the base times height. Well, the base is s times the height, which is a. And this becomes the formula for the area of a polygon. Now, what mathematicians like to do is they like to simplify things. So I'm going to go back to my black pen and I'm going to go over here and I go, they don't want s in here. They want to get rid of the s. So they say, what does s equal with respect to this? Well, if I divide both sides of this equation by n, right, and divide this by n, and divide this by n, these two cancel off, and they can say s equals p over n. And what I'm going to do is I'm going to substitute this into here for s. I'm going to bring that over here and trade p over n for s. And what I end up with is a equals n times 1/2 times p over n times a. Now multiplication is unique. These are all being multiplied. And that means the order that we do it in doesn't matter. Even the division doesn't matter. So in a sense, this an is going to multiply by p and then divide by n. Well, n divided by n is 1. So I can cancel these off, and I end up with a formula that looks like this. Perimeter times a divided by 2, or 1/2 perimeter times a. You can take your choice there. I kind of messed that up. Let me rewrite that there a bit better, a little neater. 1/2 p times a. And so a is your apotheum, your distance here, and p is your perimeter all the way around the outside. And so this is a way for you to use the formula for finding the area of a regular polygon, okay? If I wanted to find the area of this particular polygon and I knew what A was and I knew what S was, I could do it quite easily. So let's just say we're going to set A to be, I don't know, I'm going to put a blue number in here. A is going to equal 3 and S is going to equal 2. Well, all of a sudden I can go, well, if this is 2, my perimeter equals 6 times 2, which equals 12. And my area then is going to equal 12 times 3 divided by 2. 12 times 3 is 36. 36 divided by 2. Oh, having a little brain fart. Is that 18? I believe it is. 18. So it becomes 18 units. All right? Pretty simple, pretty straightforward. Area of polygons and all this kind of stuff. So I've attached some worksheets for you to practice, do some practice with respect to perimeter and area. You probably won't find this really difficult, but some new stuff, mostly stuff you've done in the past. All right, hope you enjoyed the lesson. We'll see you when we take it up.